Hello, everyone. We're gonna learn about section 7.4, the distribution of the sample proportion. So we have learning objective here. Okay, so previously we learned about sample mean of sampling distribution, right? So basically we had a mean, sample mean. So we want to estimate population mean, right? So a single mean, sample mean. Why we are doing sample mean? Because we want to estimate the population mean, right? But then we had so many sample mean, right? So that is, we have the sample mean. Hold on 1 second. So we had sampling distribution, right? Sampling distribution of a sample mean. That means we have sample mean from many samples, right? Okay, now the sample mean was the quantitative variable, right? Today we are going to learn, we already learned about the qualitative variable, right? So this section about the qualitative variable. Okay, now we have a sample proportion. So sample proportion, we had the symbol p hat, right? So read p hat. So looks like a wearing hat, like a Y hat, right? So what's the p hat then? P hat is x over n. So what's the x for? They don't say about, oh, okay. X be number of observation with a characteristic. Okay, so let's make a number of success. How about that, right? So number of success. Think number of success. 6. N is a sample size, right? So p hat is a proportion of observation in the sample with characteristic. So that is statistical approximation to the parameter p, right? So like what I said earlier, we have x bar, sample mean. So we want to estimate the population mean, which is mu, right? Then we had what? Sample standard deviation. That is S estimate population standard deviation, sigma, right? And we have sample proportion. We want to estimate population, approximate to the parameter P, population proportion, right? Yeah. Okay, so same concept as X bar, like what we did earlier, sampling distribution, right? So we're gonna have a sampling distribution in the case. So one single p hat sample proportion, we want to estimate population proportion, which is p, right? Okay, now how do you calculate the sample proportion, sorry, sample proportion? Okay, so Pew Research Center conducted here, right? Do you think the fact the US population is made up of people of many different race and the ethnicities has a positive impact on the country's culture or has a negative impact on the country's culture? Doesn't make much of a difference. The survey had 3,314 responses and 2,121 selected has a positive impact on the country's culture. Calculate the sample proportion of responses for has positive impact on the country's culture. Okay, so sample proportion, we have P hat equal to X over N, right? So X indicates number of successes, indicates how many people selected as a has a positive impact on the country's culture, right? So P hat, which is sample size 3,314. And then how many people say that has a positive impact on the country's culture? 2,121, right? Now, can you please calculate 0.6400? So 64% of people believe that ethnic and racial makeup of our country has positive impact on the country's culture, right? Okay. Okay, so we have a distribution of sample proportion here. So like earlier, what we did, we have n equal to 10 of a sample mean, and then we get 100 of them, right? Now we have sampling distribution of sample proportion. So we had n equal to 3,314. That's a huge number. And then positive impact, they have a different sample. Can you see that? I mean, number of successes. That is n equal to 3,314, right? Has positive impact. So can you see that they have all different numbers here? Yeah. Then if we make a sample proportion, the value is all different. Yeah. So we have 100 of them here too. So this is a sampling distribution of a sample proportion. Make sense? Okay. Now let us do this one. Use simulated sample data table 2. Okay, we want to describe a distribution of a sample proportion. So let's just take a look here. So we want to find the mean standard deviation for the sample proportion. So this textbook has everything. Let's just take a look. So we have a histogram for the sample proportion. Looks like a bell shape, right? Okay, now the mean. So mean we have 0.6388 for the sample proportion. So we have 100 sample proportion, right? That mean is 0.63884. The standard deviation is 0.0089. Okay? Yeah, so it's a normal normal distribution. So center mean is 0.6388 and the variation standard deviation 0.0089 and shape is normal distribution. Okay. All right. Let's take a look this one too. So we did at this one earlier, the previous section, right? Computing sample. Oh, this time is a sample proportion for the number of twos in 10 dice rolls. Okay, this time the X is the number of twos out of 10 dice. Okay, so the first one, second one, third one. Yeah. So first one, we say that how many? Two? So P hat will be number of success in the case is 2 is a success, right? So there will be 2 of 2s out of 10 sample size, right? So it's a 0.2. How about this one? P hat will equal to how many 2s? 1, 2, right? So 1 out of 10, which is 0.1. How about this one? P hat equal to, we have again 2 out of 2, right? 2 out of 2, 2 of 2 out of 10, which is 0.2, right? Okay, now we want, we're gonna take a look at the histogram, yeah? And then verify it's not normal distribution. We're gonna take a look. Okay, so the first one we found 0.2, second one we found 0.1, third one we found 0.2. And theoretical probability, we have each number we get 1 out of 6, right? So theoretical probability, we have 1 over 6, which is 0.1667, right? But then we cannot have a 6 as n, right? Because we have a n equal to 10, right? But then if we make an average of 3 numbers in that case, 0.2 plus 0.1 plus 0.2, since the 3 numbers divide by 3, that's the mean, right? So it's a 0.5. 0.5 means it's 1 over 2, right? So 1 over 2 over 3 equal to 1 over 2 times 1 over 3 equal to 1 over 6, right? Because the 3 means 3 over 1. Make sense to you? So we have a fraction divided by another fraction, 1 over 2 times reciprocal of a second fraction, 1/3, right? So which is 1 over 6. That is the same as theoretical probability. Can you see that? Okay, then your textbook said that, oh, this is the same because binomial, what's the mean? N times P. So N in the case is 10. And what's the probability? 1 over 6. Then we get 1.667. Then, oh, we have a 1.667. But then theoretical probability is 0.167, right? Then we divide by 10. Then we get the 0.1667. Make sense? So they say that the mean of distribution of a sample proportion equals the probability of success in the binomial experiment. Yeah, that's why I say that the X is number of successes. Make sense to you? All right. Okay, now let's take a look this one, this table. So we have sample number of twos, 2, 1, 2, 1, 2, 2, 2, 2, 2, 2, 2, and so on, right? And sample proportion 2 out of 10.2, 1 out of 10.1, 2 out of 10.2, and so on, right? So we have a sample proportion there, and then 100 of them, right? Okay, so histogram, just take a look, right? So what do you think about this one? So we have like this. Yeah. Skewed right? Yeah. We know this is non-normal, right? How do we check whether normal or not? So in binomial distribution, we check that n times p times 1 minus p greater or equal to 10. We say the normal distribution, right? Okay. So let's just check that. This is the one. Yeah, this is the one. So n times p, 1 minus p. This is n, 10, and then probability 1 over 6, 1 out of 6, yeah? And 1 minus p, so probability is point 1667, right? So 1 out of 6 is a point 1667, all right? So they calculate, we got the 1.39, which is less than 10. So this is a non-normal, okay? Non-normal, yeah. Okay. Now, everything is previous stuff. What about this one? Central limit theorem again, right? So we have a central limit theorem for proportion. Okay, we had earlier central limit theorem for sample mean, right? So we had center mean was, let me write down, for mean, we had center mu sub x4 was, what was it? Mu, right? And variation, sigma, right? So sigma sub x4 equal to sigma over square root of n, right? And then shape, how did we do? The original one, normal distribution, or, okay, either x is normal, or we check the sample size. The n must be greater than or equal to 30, right? That's the sample size. Then it's a normal distribution. Yeah, we have to have a normal distribution in order to use a StackCrunch stack calculator normal. Otherwise, we cannot use that, right? Because that's not the normal distribution. How can we use that, right? That's why we have to check that shape. Either the original one is normal or sample size must be greater than or equal to 30. Why? Because when any set gets bigger and bigger, increasing the distribution approximately bell shape, right? So how do we check how much bigger? So n must be greater than or equal to 30. Make sense? Okay, now we have a central limit theorem for proportion. Okay, so I just showed you earlier the mean of sample proportion, same as theoretical probability, right? So it's a population proportion, same. We can say that, right? So that is a population proportion. Okay, now variation, standard deviation, little bit complicate formula, right? Square root, inside the square root, we have a p times 1 minus p over n. So like a binomial, p and 1 minus p there, right? Yeah. And shape, approximately normal, oh, like a binomial, right? Because why? Because we are using x as a number of successes, yeah? And mean was the same as n times p, binomial distribution. We said earlier too, right? Okay. So n times p times 1 minus p greater than or equal to 10. Okay, so Let's take a look. Note that additionally to ensure, X is a binomial random variable, we need to know that the trials are independent. Independent. That means the sample size must be less than 5% of population. So in that case, the earlier independent, the outcome of A does not affect the outcome of B, right? Now, we talk about the trials, N is independent. So in that case, how do we know outcome of A does not affect outcome of B? That is 5% of population size. Very tiny, right? 5% of population size. So we can assume that outcome of A does not affect the outcome of B. Independence. Yeah. All right. Okay, so let us do this question example. According to the U.S. Public Interest Research Group's Education Fund report, 65% of college students in the US have skipped purchasing textbooks for their class due to cost. And assume the sample size of sample of size 160 are randomly selected from population of college students in the US. Let P hat equal to X over N be the proportion that have skipped purchasing textbook. Describe sampling distribution of a sample proportion. So similar with the earlier section, previous section, sampling distribution of a sample mean, right? So we check the mean, standard deviation, and so basically center variation and shape, right? So check it out. Check the mean variation and center variation shape, right? Okay, so center, which is mean, right? So mean mu sub p hat, what do you get? It's a p, right? So population proportion. So this will be p, 65% will be p. So that is 0.65, right? Okay, and variation, standard deviation, sigma sub p hat. So we have a formula, square root p 1 minus p over n. So p, which is 0.65, 1 minus 0.65. Over n, how many n? 160, right? Can you calculate? Yeah, so there will be 0.0377. Yeah. Okay. Let's check the shape. Yeah. So we have to check show n times p times 1 minus p must be greater than or equal to 10 for normal, right? Okay, so n times p, n equal to 160 times p 0.65, 1 minus p, which is 0.65. Can you calculate? 36.4 Yeah, it's greater than or equal to 10. It's a normal distribution, right? Yeah, it's normal. Very good. This is low. Okay, so this question will be last question for this section. Let's do it. According to Institute for Health Matrices and Evaluations, approximately 82% of US population has been infected with COVID-19 at least once as of July 2022. And sample size is 200, randomly selected from US population. Okay, the first one describes the distribution of sample proportion for those who have been infected with COVID-19. So this is what we just did, right? So describe the distribution of a sample proportion. So we describe center variation shape, right? Okay, so first one, mean mu sub p hat, which is p, which is 0.82, right? So this is p, population proportion. Okay. Sigma sub p hat, which is square root of p minus 1 minus p over n, right? So your turn. P, which is 0.82, 1 minus 0.82 over n, which is 200, right? What do you get? So 0.0272. Okay. 0.0272. Okay. Now the shape. So we check the n times p. N times p times 1 minus p must be greater or equal to 10, right? So n, which is 200, p, which is 0.82, 1 minus p, which is 1 minus 0.82. Please calculate. So we got 29.52, which is greater than or equal to 10. So it's a normal distribution, right? All right. Now, second part. We want to estimate probability, yeah, less than 75% with, okay, so we are going to use a StatCrunch. Listen, this is only the one question we are using StatCrunch in this section, right? So we will set up this way. Probability of p hat less than 75%. So there will be less than 0.75. Make sense? So there will be less than 0.75. Okay, now we are using mean 0.82, standard deviation equal to 0.0272. All right, so StatCrunch with a mean. Let me using as a word because there is a word, right? Mean equal to 0.82 and standard deviation is 0.0272. Okay? All right. Now, the third one, a little bit different. So I'm gonna read, use the sampling distribution for the sample proportion to estimate probability that sample of 200 would have 175 or more. COVID-19 infections. Look, A part, the 75% is given. B, I'm sorry, the C, they don't give it to us a percentage, but we can calculate. So we can use this one as a P hat. Yeah, so P hat, which is X over N, which is 175 over 200. Can you please calculate? 175 divided by 200, which is 0.875. We are using that. And then they say that more means it's greater, right? Okay, so let's using that. See, P, probability of P hat greater than 0.875. Using StatCrunch, same mean and standard deviation, right? So let me take a picture and then we using StatCrunch. Okay, so I wrote down the probability here, okay? Thank you for watching. I will see you in next video. Bye-bye.